Today's tinkering is accompanied by Bellhop Vanilla Bourbon Porter from Torque Brewing in Winnipeg. They describe it as having flavors of chocolate, toffee, vanilla bean, and dried fruits. Approachable enough for the novice, yet refined enough for the connoisseur. Not quite sure where I fit in there, but I'm going to enjoy it regardless. I'm going to guess that regulars to this channel probably appreciate addressable LEDs almost as much as I do. And this is one of the form factors that they come in. They also come in strips and various other things, rings like this, or straight sticks, or many other different form factors. But what you can't get is like 10-watt and bigger versions of them. At least not that I'm aware of. So that is my experiment today, is to see if I can control one of these really high-powered LEDs using the WS2811. As you may recall from the last mailbag, I got a couple of packages of WS2811s, and what they are is this little SOP8 chip, which basically interprets the data protocol of the addressable LEDs. The WS2812 is typical, but this one doesn't have an LED attached to it, so you can attach anything you want within reason. As a matter of fact, inside each of these ones here is a WS2811 and a four-legged RGB LED. Here is one of these that I stripped all the weatherproofing off, and you can see what's inside it. It is the same WS2811 chip. There's the 4 pins going up to the RGB LED, so there's a common and a red and a green and a blue pin. Other than that, we have one resistor and one little capacitor, and then the power wires, data coming in, data going out, and the power wires are repeated on the back of this little board. And you can actually buy these little boards as a separate item as well online. You can get them either pre-populated with the chip and no LED and supply your own LED, or just the blank board and then you put your own chip on them, which may be an interesting experiment for the future, but that's not what I'm going to do right now. What I'm going to do is take some of these guys and put them onto just some of these little surface mount carrier boards so that I can plug them into breadboards and do some experiments. Might as well take a quick look at the WS2811's data sheet before I solder everything up, just so I know what I'm doing. It looks like it can handle a wide range of voltages. It's got a built-in voltage regulator, so you can run up to 24 volts for the VDD, the power in. I'm going to run it off 5 volts initially here, but you just add a resistor if you want different voltages, which is kind of cool. It's also got some protection resistors in the data in and data out ports for overvoltage protection. Looks like it's designed to be operated in fairly unpredictable conditions and with rough handling and not too careful handling, which is perfectly fine because I suspect a lot of these pixel strips get pretty rough handling over time. Another resiliency point is that it can run up to 4 meters between pixels without having to put any buffering or anything in between, which is kind of handy. And just like the WS2812s or NeoPixels or anything like that, you can run up to at least 1024 pixels before the timing starts to cause problems, which is an awful lot. And then if you need more than that, you just run separate data outputs from your microcontroller or whatever, and you can control them that way. So I've described this before, but basically the data input receives data from your controller. It grabs the first 24 bits of data and then passes the rest of it on to the data out port. And then that first 24 bits gets pulled into an internal latch and processed and turned into the red, green, and blue outputs. There is a pinout of the chip, red, green, blue, ground, voltage, no connection, data in on pin 6, data out on pin 5. The limiting factor that is leading me towards this entire project that I'm doing today is this right here. It can supply about 16.5 milliamps to each LED. And actually, it's got a current limiter or current regulator inside, so that that's all it provides to the LED, no matter what color the LED is as well. Normally, red, green, blue LEDs have a different forward voltage on them, as we've seen in the past, but this is essentially a constant current. Well, it says right there, constant current driver. So that is what it's giving, is 16.5 milliamps, which for a 10-watt LED like I want to use is way inadequate. And there is the sample circuits. Very straightforward. Data comes in, data goes out, data comes in, data goes out. The 3 LEDs there. Then a series resistor to the voltage regulated input. And again, that is not generating current for the thing. The chip switches to the ground. So we've got 5 volts for the LEDs coming from up there, and the common ground down there with the regulation in the middle of it. So if you want to run on a higher line voltage, 12 volts for instance, you just run 3 LEDs in series, and then again this regulates it to 16.5 milliamps, and you use a higher value of resistor for powering it, and the internal regulator takes care of it. Similar with 24 volts. So with all that out of the way, I've got one soldered up onto a board here. I've got a 150 ohm resistor like it showed on the data sheet going to the power. This is 5 volts, so I probably didn't need that, but I'll put it there anyway. And then I have this RGB LED hooked up to pins 1, 2, and 3, and it's common going to the power rail there. And just to demonstrate that the data in and data out are working, my controller is actually over here feeding in there through these 2 LEDs, which are RGB with WS2812 built into them, or 2811 probably. They are 8mm LEDs. An alternate to doing this, and I'm not sure why this is preferred to that. Maybe those are just more costly. I don't know. Regardless, that's an aside. Then the data in out, into this strip, out from that strip over to our individual chip here, then data out of there back into this, and I can keep going if I want to, but that proves the point, and that's what I needed this to do. I could also, if I wanted, put separate LEDs on there, but I mean that gets this working, and that shows that is how it works, but that's just an interim step. So I've built this circuit here, and I will show it to you a little bit more carefully when I get it powered on, but in the meantime we'll just get 5 volts and ground from over there. We'll get the data out signal from this guy, and you can see that this 2811 has a green and a red LED connected to it. It's green and red channels, and then this white wire comes out of the blue channel and goes over to this optocoupler. And I decided to use an optocoupler there after much experimentation with cascading multiple transistors and stuff, but that just seemed like a simpler solution because this thing is designed to drive a current limited LED, and it's switching to ground. So why not just give it an LED, which is what's in an optocoupler? So the blue channel goes out to the optocoupler. The other side of the optocoupler goes up to positive there. So that's the LED side of the optocoupler down there, and this is the transistor side. It's an NPN transistor inside there. So we have ground going to one side of it, and that's the emitter, and the collector is going through this series resistor over to the base of this transistor here. So then the collector of that transistor is coming out to this 10-watt LED, which I'm powering off a separate power supply, 10 volts, and that's just common grounded there. So when I turn that on, this is acting as the blue channel of that WS2811 there. Let's just reset this to something a little bit different, so we've got red, green, and blue happening. I don't have a lot of PNP transistors, but the one that I've chosen is good for about 600 or 700 milliamps. I'm not running it at anywhere near that at the moment, but it's good for that. If I wanted a bigger LED over here, I could just swap out for a bigger PNP transistor, but like I said, I don't have any, which is odd because I tend to like to have a lot of variety of components in stock. I could probably put a P-channel MOSFET in that position as well, but again, I don't have any. I seem to have mostly N-channel and NPN stuff around here because that's just what I'm used to, I guess. So it really is that easy I don't see any reason why I couldn't go bigger. Like I said, if I had a bigger PNP transistor or if I had a bigger LED, I could probably get a lot more oomph out of that. But that is definitely really quite bright. Yeah, that is blindingly bright. And that's only drawing about 90 milliamps at the moment. So that is absolutely what I wanted to find out from today's experiments. Have you guys played with these 2811s directly? I mean, anybody who's used these things has already played with them without even knowing, probably. But have you played with any bare ones? Do you know of any other experiments or any other projects that have sought to do this? Although, other than just tinkering, why would you want to do this? Oh, I suppose if you had a Christmas light display that was all running on programmed WS2812s, you could have a few of these to spotlight things with the proper optics and stuff, or things like that. And actually, come to think of it, you could power anything off that transistor. You could run a DC motor off that for an effect of something. And again, just all program it through your lighting software. The sky's the limit. It may or may not be practical, but it sure was fun. Thanks for watching. I appreciate that. Questions and comments. And yeah, if you have any other ideas about this project, I'd like to hear about it. Talk to you later.